Namaste everyone, hope all of you are well. Actually, today we are going to discuss class 11 chapter number 7 equilibrium, lecture number 5. This is class 11 chapter number 7 equilibrium. This is the fifth lecture. In all the four lectures we have discussed about that what is chemical equilibrium, how we are calculating the concentration. I just want to give you a little bit rewind after what things we have studied in the main lecture number 1, lecture number 2, lecture number 3 and lecture number 4. In lecture number 1 we have discussed about the types of reactions, in which I have told you about the reversible reaction. After that I have talked about the chemical equilibrium. Equilibrium has been divided into the two parts, that is physical and chemical. In the chemical, Lecture-5 principle according to the concentration, pressure and temperature, and in physical equilibrium all the phase transformation from solid to liquid, liquid to vapor, vapor to solid. These are all the things we have studied here. Just suppose here I am talking about a reaction A plus B, chemical equilibrium C plus D, and here for the forward reaction this is R1 and for backward reaction this is R2, and I have calculated here that rate constant is equal to the concentration of product upon the concentration of reactant. These are all the things we have studied in the previous video. Hope all of you have understand that what things we have understand in the previous video, that what is chemical kinetics, equilibrium state, and everything the rest of the things we have understand. In this video especially I am going to describe you about after understanding the phase transformation, the dynamic equilibrium, that equilibrium which has the equilibrium state either in the physical, or if I talk about the chemical equilibrium, here as I have shown you the reaction, considered a reaction, reversible reaction, A plus B is equal to C plus D, when this R1 is equal to R2. R1 is equal to R2 means if I talk about Kf is equal to Kb, means rate constant of the forward reaction is equal to the rate constant of the backward reaction. When these both are equal, means they are in the equilibrium state, then you can say that this is a dynamic equilibrium, dynamic reaction you can say. So here I have just considered a normal chemical equilibrium reaction, that A plus B is equal to equilibrium C plus D, and I have just given the calculation of the rate constant K is equal to concentration of product upon concentration of reactant. So if anybody will ask you what is chemical or dynamic equilibrium, then you can say a chemical reaction reach to a state of dynamic equilibrium in which the rate of forward and the rate of backward reactions are equal, and there is no net change in the composition. Means if I talk about that in the product or reactant, either in the forward reaction or in the backward reaction, if there is no change of product, means you can say A plus B will give C plus D and C plus D will give A plus B. So as you can see here in the concentrations of the reactant and product there is no changing, then you can see that this reaction is dynamic reaction. Now if I talk about the law of chemical equilibrium and the equilibrium constant, so here the equilibrium reaction as we have just considered only, and you can say here the equilibrium constant Kc is equal to the same thing as the concentration of the product upon concentration of the reactant. But here one thing I just want to say you, if I talk about the coefficients, means if any number of, just suppose here A, number of moles of this reactant A, number of moles of reactant B, C and D. So here there will be a raise to, the C raised to C, D raised to D, A raised to A and B raised to B. Means just I want to say that if I talk about the coefficient, number of A molecules, number of B molecules, number of C molecules, number of D molecules, then this number of molecules will be directly in the form of expression, as you can see here, as C raised to C, D raised to D upon A raised to A and B raised to B. Now let's discuss some of the reactions, that how to write these reactions. If I talk about, just suppose here hydrogen and iodine gives you 2Hi. So this is your chemical equilibrium reaction. Okay, means H2 plus I2 gives 2Hi and 2Hi gives H2 plus I2. This is an equilibrium reaction. So if I talk about here the value of concentration constant Kc will be equal to that HI concentration raised to 2 upon H2 concentration and I2 concentration. Means the concentration of product concentration, HI concentration, and the number of molecules is here in the form of exponent. Similarly, if I talk about the reactants, so in the reactant also you can see that the concentration of the reactant, since here there is no numbers, means whatever molecules are there, so no need to write in the form of exponent as over. So this thing, now let's discuss some of the questions given in the NCERT, that is problem 7.1. Okay? So let's discuss with the problem 7.1. We will today discuss some of the problems only, and in this problems we are going to understand the concept that how to do the reaction. There is one reaction of ammonia. How ammonia is formed? N2 plus 3H2 gives 2NH3, right? So here, if I talk about the concentrations of these reactants, values are given in the question. Okay, let me read a question. The following concentration were obtained in the form of NH3 and N2 and H2 at equilibrium at 500 Kelvin. So the concentration is given. Here in the question, concentration is given. The concentration of, first of all, the reaction is nitrogen plus hydrogen equilibrium gives 2NH3, right? So here the concentration of nitrogen is given. Concentration of nitrogen is equal to 1.5 into 10 to the power minus 2 molar. Here if I talk about the concentration of hydrogen, then it is given 3.0 into 10 to the power minus 2 molarity. And here NH3 concentration, it's equal to 1.2 into 10 to the power minus 2 molarity. So here you can see, if I talk about the concentration, you know very well that how to calculate the concentrations. So can you tell me first of all, what will be the value of Kc? Kc is equal to, concentration constant is equal to the concentration of product NH3 raised to 2. Why? Because it is 2 molecules. And here in the reactant side, concentration of nitrogen and concentration of hydrogen raised to 3, because here hydrogen is 3 molecules. So here the concentration values are given. You can see NH3 value is 1.2 into 10 raised to minus 2 to the power 2 upon the value of N2 is 1.5 into 10 raised to minus 2, and the value of H2 is 3.0 into 10 raised to minus 2 to the power 3. So as you will do the calculation, how you will do the calculation? Here is whole twice, means 1.2 into 1.2 into 10 raised to minus 2 into 10 raised to minus 2 upon 1.5 into 10 raised to minus 2 into 3 into 3 into 3 into 10 raised to minus 6. 2 3s are 6. Okay. So here, if I talk about 1.44 into 10 raised to minus 4 upon 3 3s are 9, 3s are 27 into 1.5. 1.5 into 27 into 10 raised to minus 8. Okay. So here, if I talk about, if you want to cancel by 3, then you can cancel. How you will cancel by 3? Just see here. 3 5s are 15, 0.5. 3 4s are 12, and 3 8s are 24. So 0.48, right? Now if you want to divide this, so here, so let us write first of all 0.48 into 10 raised to minus 4 plus 8. What I have done here, this 10 to the power minus 8 has gone up, so it became minus 4, and here half multiplied by 27, so 13.5. Okay, so now here if you divide this, just you can write here as in the form of 4.8 into 10 to the power 4, sorry, 10 to the power 3, not 4, 10 to the power 3 upon 13.5, right? Yes. So after dividing 4.8, if you divide by 13, 0.5, right? So what will be the value? As we divide here, the value will be 1.06. Or if you want to do, just see here. Here it will be 4.8 is 48 by 10, and here 135 upon 10, right? So here into 10 to the power 3. So here 480 upon 1350. 1350, that will be 0.6. 0.6, if you divide, just see here, 48 divided by 135. So 1.06 here it is then 0.106. 0.106 into 10 raised to 4 or 3 you can write here. Here 10 raised to 4, and after dividing that 1.06 into 10 to the power 3. In this way you can calculate the concentration. Similarly, if we talk about the second question is about the nitrogen and oxygen, and same thing, nothing else, we have to just do the calculation. If you know the calculation, then it's very easy. So it's very easy to do calculation. If you get a mistake in calculation, then no need to see. First of all, if you want to do calculation here only, if you want the full calculation, sir, you want full calculation, how it has been cancelled, वगैरह वगैरह. So what you have to do, just I am showing you. See the values we have put here, okay. Now directly put a slash here, and here the values 12 upon 10 into 12 upon 10, okay. 12 upon 10 into 12 upon 10, 10 to the power minus 2 into 10 to the power minus 2, okay, upon 15 upon 10 into 10 to the power minus 2 into 27 10 to the power minus 6, okay. So now you can see the things which are going downside, we can take downside. Say 10 to the power minus 2, 2 times you can cancel it. Otherwise, if you don't want to cancel, this 10 will go up and this 2 10 will come down. So what will be there here? 12 into 12 into 10 to the power minus 4 upon this 10 will go up, okay. And this here 15 into 10 to the power minus 2 into 27 into 10 to the power minus 6, okay. And this both 10 will come down into 10 into 10, okay. So now see here, 3 4s are 12, 3 5s are 15, 3 4s are 12, 3 9s are 27, okay. Now does it, yeah. So here 4 4s are 16 and 5 9s are 45, okay. Now you can see here it became 10 to the power minus 3, and here at down 10 to the power 2, and this 10 to the power minus 6, okay. So here 16 upon 45 into 10 to the power 3, right. See here, this 10 to the power minus 2 and this 200 has been cancelled. 10 to the power minus 6 has gone up. This 10 to the power minus 4 and 10 to the power minus 3, and here 10 to the power minus 6. Now this 10 to the power minus 6 has gone up, so it became a positive. Now you can take here 160 upon 45 into 100, or 10 to the power 2. So here if you cut, 45 2s are 90, right? 45 2s are 90, and 45 3s are 135, right? So 45 3s are 135, 50 150, 45 3s are again. So the real values is, it's not becoming 1.06, right? It's wrong, value is coming wrong. So here the answer will be just divided, okay. If you want to divide by 12 5s or in the form of 5, yeah. Just put here, just suppose that here it is 16 only and here we have taken 1000. Okay. So 5 nines are 45 and 5 200s are, so 16 into 16 2s are 32 into 100 upon 9. 9 3s are 27 point 27 and 5 32 50, 9 5s are 45, 3.55 into 10 raised to power. This will be the right answer. Okay, in the NCERT it's given wrong. 1.06 is wrong answer. Yeah, I'm sure it's wrong answer. Okay, so this will be your right answer, 3.55 into 10 to the power 2. Now let's come to the second question. All the answers can't be wrong. So let's see that what's the second question is saying. If I talk about the second question, in the second question N2 plus O2, it's given similarly. N2 plus O2, 2N. N2 plus O2 gives 2N. Okay, and here the concentrations are given. The concentration of N2 is 3 into 10 to the power minus 3 molecular molarity. O2 is 4.2 into 10 to the power minus 3 molarity, and NO is 2.8 into 10 to the power minus 3. Okay, let us discuss this question, that the answer of this question is right or wrong. So automatically you will get that NCERT is right or I am. So no need to worry. Now just see here. The concentration constant Kc is equal to concentration of the product, concentration of NO to the exponent 2, and concentration of N2 and O2. N2 and O2. So NO value is 2.8 into 10 to the power minus 3 to the power 2 upon N2 value is 3.0 into 10 to the power minus 3 and 4.2 into 10 to the power minus 3. Okay, so here now just see 2.8 into 2.8 into 10 to the power minus 6 upon 3 into 4.2 into 10 to the power minus 6. So 10 to the power 6 cancel. 8 to the 16 and 5.6. So here just suppose this 28 upon 10 into 10 into 3 into 4.2 and here into 10. So 10 cancel. 14 2s are 28, 14 3s are 42. Right? So here 28 2s are 56 upon 90. 28 2s are 56 upon 90. Yeah, 0.622 right answer. So 0.622 will be the constant. Yeah, in the first question the NCERT answer is wrong, I'm telling you. So just go through that answers. Definitely you will get. Sometimes it has printing mistake or calculation mistake. They may have got it. So no need to worry. Okay, so this was our second question. Hope all of you are getting the answers. It's very easy. Now we are going to calculate the equilibrium constant in the gaseous system. Now in the gaseous system, as I have told you, that PV is equal to nRT, and we have got the value that Kc and Kp relationship, we have found it. If we have remembered, then Kp is equal to Kc RT to the power delta Mg. I have shown you that, right? So here the same thing, PCl5, PCl3 and Cl2 are at equilibrium at 500 Kelvin and having concentration of 1.59, molecularity of PCl3, 1.59 molecularity of Cl2 and 1.41 molecularity of PCl5. So let us calculate the equilibrium constant. After calculating the equilibrium constant, same question, nothing else, so no need to worry. It's the same question that PCl5 gives PCl3 and Cl2, right? So the Kc is equal to concentration of PCl3, concentration of Cl2 upon concentration of PCl5, right? And here the values are given. The concentration of PCl3 value is 1.59. 1.59. Here also 1.59, and PCl5 value is 1.41. Means here 1.59 into 1.59 upon 1.41. So you have to do calculation like 159 into 159 upon 100 into 100 and 141 into 100. So this 100 cancel. Now 159 into 159. You have to just do the multiplication and you have to do the division. So let us see that what is the value of this 159 into 159. 159 into 159 is 9 9s are 81, 8, 9 5s are 45 and 8, 53, 9 5, 40, 5 9s are 45, 4, 29, 2, 7 and 159, right? So 1, 8, 22, 50, 25 to 81. So here it's 25 to 81 and 141, 141 into 100. So if you divide this number by 141, so whatever the value you get, 141s are, so 1, 5 minus 4, 1, 1. Because it's 282, right? So here 8. 3 that will be, if I talk about 47. So 7 1s are 7, 7 4s are 28, 2, 7 2, 9. Yeah. Or 8s are, just take 7 only. 8 minus 7, 1, 11 minus 8, 3, 1, 131, and here 8, 13, 18. So if we take 8 then here it will be 8 1s are 8, 8 4s are 32, 3, and 83, 11. It will be 9, I think so. 9, so let's see, 9 1s are 9. 9 4s are 36, 3, and 9 1s are 9, 3, 12. Yes. So here 18 minus 9, 9, 10 minus 6, 4, 49. So here 179, 0.17 I think so. So let's see what's that. 1.79. Right answer is 1.79. Because you can see after dividing this, here something 179 or something, just suppose here 0 upon 100, right? So here after 2 digit 0, 17.90. So this is the concentration constant of this question. This one, second one. This reaction's concentration value is here 17.90, but only here we have to calculate the same thing, yes. But in the next question, the value of concentration constant is given. Now you have to calculate the equilibrium constant. Now this is the nice question. Yeah. Right? So this is the nice question. I hope that you will understand in the problem 7.4. So let's start problem 7.4 first of all. Yeah, in this question, it's very easy, no need to worry. Carbon monoxide plus water gives carbon dioxide and hydrogen, right? And here the initial concentration in the question is given that the value of Kc, rate constant, is 4.24 at 800 Kelvin in this reaction. Calculate the equilibrium constant of carbon dioxide, hydrogen, carbon monoxide, water at 800 Kelvin. If only carbon monoxide and water are present initially at the concentration. Initially it was 0.1 molecularity and 0.1 molecularity, and they both are 0, right? Now, no need to worry. See, first of all, what we have to do, we know very well that initially they are 0.1 mm, and now just suppose that they have become X. So what will be here? Now just suppose here carbon monoxide and hydrogen or water, you can say, it was earlier 0.1 molecularity, and that carbon dioxide and hydrogen is 0. But now they have become 0.1, 0.1. Okay? So what will be here? Now you know very well, if they have become this, means from reactant side this has been minus. So what will be here? 0.1 minus X, and here also 0.1 minus X. And finally, in the question it's given that rate constant value, it's given, right? Rate constant value is given. So you can say here that concentration constant is concentration of X upon concentration of reactant 0.1 minus X and 0.1 minus X, right? So here the rate constant Kc, X square upon 0.1 minus X whole square, and this value is given in the question. What is this value now? This value is 4.24. The value of Kc is given in the question, that 4.24. 4.24 is equal to X square upon 0.1 minus X whole square. So you can just take here that 4.24 into 0.1 minus X square minus X whole square is equal to X square. Yeah, if you want to write the equation, then you can write here that first of all 4.24 into, now you can write here, this is a minus b whole square. A square means 0.1 upon 10 into 0.1 upon 10, 1 by 10 into 1 by 10, 1 by 100, 0, 1 minus 2ab 0.2x and plus x square is equal to x square, right? Now you are multiplying by 4.24, so 4.24 into 0.1 upon 100 upon 100. Now, so it will be after 4 zeros, means 0.424 minus 2 and 3 zeros, so 8, 4, 8, 2 and 3 0, 8 point or 0.848x and plus 4.24x square minus x square is equal to 0. Now this became a quadratic equation. So now 4 point minus 1, so it will become 3.24x square minus 0.848x plus 0.424 is equal to 0. So this is a quadratic equation. In this quadratic equation, we have got the value of 0.0424 here, sorry. Here it will be one more 0. 0.0424. So 0.0424. Here this is a quadratic equation. A is equal to 3.24, B is equal to 0.848, C is equal to 0.042. Now you have to find out the value of x. X is equal to minus b plus minus under root d upon 2a, where d is equal to discriminant, d is equal to b square minus 4ac, right? So here b value is already in minus, it will become plus 8.48 plus minus under root 0.848 whole square minus 4, a is 0.0424 into 4 is 3.24 upon 2a, means 2 into 3.24. So whatever the value is given, if you don't know because it is a long calculation, so now the final value of x1 and x2, that's 0.067 and 0.194. There will be 2 plus 1, 0. So x1 and x2 value is 0. You can see this value we have to just write it, that is 0.067, 0.067 and 0.194. Now this values, whatever the values I have been given, what is this? This is, we are calculating the constant term. Now 0.19 should be neglected because it will give the concentration of reactant which is more than the initial. You can see in the initial it is 0.1 and here 0.1 means 0.10 and x2 is 0.194, so it will be neglected. So the value will be, x value will be 0.067, right? Now if I talk about 0.667, the carbon dioxide value is 0.67. So what will be the value of carbon monoxide and water? See here, already this value is given here and this value. Now you can see here that x1 value is 0.67 and 1.94. 1.94 will be greater than initial, right? So it can't be. So this value is not possible, right? So here carbon monoxide and H2O value is given. How much? That is 0.1. So now if you want to calculate the carbon dioxide and hydrogen value, then you can say that it will be 0.1 minus 0.067. So here 10 minus 7, 3, 9 minus 6, 3, and this will be 0, right? 0.1 minus 0.1 minus 0.0. So this value will be 0.033. 0.033 molecule means molarity, you can say. The value of this carbon dioxide and hydrogen will be 0.033. See, first of all, I just want to say in this video that you have to calculate all the numerical problems which is given in your NCERT example, correlate this example with the exercise question and then do the solution. I hope that it will get more and more beneficial when you correlate these examples to the exercise question, when you don't know the answer. Here the answers are given, but when you calculate these values, It's just to make you understand that how to calculate this value. That's all for today. Hope all of you understand. If you have understand, then don't forget to like and subscribe to the channel. That's all for today. Thank you very much.